Good morning or good evening, everyone. My name is Sakhar. I'm a PhD student at Columbia University. I hope you are all doing well. I'm going to talk about natural language processing for Arabic language. So here are the agenda. I'm going to start first with the natural languages, and then talk about Arabic language specifically, then give overview of natural language processing, its applications and tools, and then Arabic NLP, some datasets and tools. So what are natural languages? They are any language that has evolved naturally in humans. Examples include Arabic, English, French. Unlike constructed languages like programming languages, Python, Java, C, they aren't designed, so there's no previous grammar rules for natural languages, and they are inherently ambiguous, which means that you might have one word that has two meanings, like the word bank can be river bank or financial bank. Also, it's worth mentioning that all human language varieties in the world are natural. However, there are some efforts to standardize languages. Some languages have more standardization than others. For instance, Modern Standard Arabic or Fusha has different language academies. French language also has French Academy, while English does not have academy that regulates English. Language prescriptions include dictionaries, so linguists design dictionaries, list of words, their meaning. There are some languages that regulate orthography or spelling, like the German language. Also, prescriptions include grammar. And in real world, people do not follow these standardization. So people not necessarily speak exactly as the prescriptions given by the language academy. Arabic is one of the UN official languages, and it's the sixth most spoken language in the world, with more than 360 million speakers. And it exhibits an interesting linguistic phenomenon called diglossia, where two or more varieties of the same language are used. So in Arabic, people speak both Modern Standard Arabic or Fusha and different dialects. These dialects are different than MSA in different ways. They have different lexicon. They have different morphology, which means that words have different structure between different dialects and the MSA, and they have different grammar as well. MSA or Fusha is mainly written. It's well regulated. There has been a lot of effort in standardizing and regulating MSA. However, it's no one's native language, so people do not learn Fusha in natural way. They learn it at school, and it's used in formal situations. On the other hand, dialects are mainly spoken. They are used in daily basis, and dialects are a native language for Arabic speaker, and they are dominant in social media. Also, too, in linguistics, we say that two languages are dialects of the same language if they are mutually intelligible, which means that you can understand each other if you speak two different dialects. But if you don't understand each other, that means they are completely different languages. So for instance, Italian and French, even though they are related, but they are different languages because it's hard to understand each other if you are a speaker of French and you speak with someone who's a speaker of Italian. But if you are Egyptian and you speak with someone from Saudi Arabia, it's easy for you to understand each other. And here's a map of the distribution of Arabic dialects. You can see here in Saudi Arabia, there's the Najdi dialect in the central region. It covers also some parts of Jordan, Iraq, and Syria. You have the Hijazi dialect on the west coast. You have the Gulf dialect and Bahraini dialect. And now I'm talking about natural language processing. So what is natural language processing? It's also known as computational linguistics. It's intersection between computer science and linguistics, particularly artificial intelligence. And it aims to study and design language technologies like spelling correction, machine translation, text analytics. And it's worth mentioning that most of NLP problems are AI hard and still unsolved. So why do we need NLP? In fact, most of our communications as humans in unstructured structured format. Also, human language is hard to model. As I mentioned before, natural languages are inherently ambiguous. So a word like bank could be something like river or financial institution. Also, people sometimes express things without meaning the literal meaning. So sometimes they are being sarcastic. They don't exactly mean what they say. So here's an example when you say now Mac supports Windows, and people associate it with this meme, which is macaroni and cheese cereal supporting like actual Windows. So they are being sarcastic here. They don't really mean that. They mean something else. And there are lots of challenges in the NLP field. One of them is scale. Sometimes we need to deal with large scale, a tremendous amount of data to do some real-time processing. Also, we have to take into account language variation. You have a lot of languages. Each language has its own dialect. And another challenge is unknown representation. We don't know how to represent the word knowledge. We don't know how to represent some concepts like common sense. How can we represent common sense to machines? So these are some examples of challenges within the field of natural language processing. And NLP technologies can be divided into two categories: applications and core technologies. We'll talk about each of them briefly. Next slide. So let's start with applications. One of the most known applications for natural language processing is machine translation. I believe most of you have used Google Translate. So here's an example from Google Translate, translating text from Arabic into English. Another application is sentiment analysis. The goal is given some text, you want to say that is this positive, negative, or neutral. Another application is text classification. You have a set of documents, you want to assign them to predefined classes. So if you have some news articles, you want to classify them into sports, science, politics, etc. And here are some NLP terminologies. I'm going to talk about them in a moment. Usually hear the word corpus in NLP in linguistics. So what is a corpus? Corpus is just body in Latin. And in linguistics and NLP, we use it to refer to a collection of text. And this collection of text can be in single or multiple languages. So in case that's multiple languages, we call it usually parallel corpus. Like the Rosetta Stone, it's one of the oldest examples of corpora. And corpora can belong to different genera like news articles, social media, etc. You can have like a corpus of field reviews or tweets, Wikipedia articles, and usually corpora are annotated with some information. Like tweets, you can have a corpus of tweets annotated with sentiments, or field reviews annotated with score. Wikipedia articles annotated with topics. In this case, sometimes it's self-annotated. And yeah, annotation process is done by humans usually. We talked about some NLP applications. There are other technologies. We call them NLP core technologies. So these technologies are used in the pipeline for other downstream tasks like machine translation, sentiment analysis, text classification. We use for these applications different NLP core technologies. Examples for core technologies: tokenization and segmentation. It's the process of splitting text into smaller units. So you have like a document, you split it into paragraphs, or paragraphs into sentences, sentences into words, and so forth. Another example is lemmatization and stemming. It's reducing words into their base format. So in this example, you have studies, studying, studied. You reduce them all to study. Lemmatization and stemming are useful to reduce the noise, and sometimes you don't need all of that information for some applications. Other examples include part speech tagging, named entity recognition, parsing. I'm going to talk about them in the next slide. So what are part speech tags? They are also known as lexical categories like nouns, verbs, adjectives. So the task of part speech tagging is to assign for each word or token one of the part speech tags. The tags can be coarse-grained, like noun, verb, adjective. So you have a small number of tags that cover a larger number of tokens, or can be fine-grained, like nouns. You can say this is proper noun, this is singular, this is plural, etc. Another NLP core technology named entity recognition. It's a subtask in information extraction. So in this task, we are interested in classifying named entity categories. So you have some named entities, and you want to say, okay, this is person, this is organization, this is location. So in this example, you have Aramco is organization, Dhahran is geopolitical entity, Amin and Nasser is a person. And here's an example of tokenization, part speech tagging, NER, and lemmatization using Magamira system for Arabic. I'm going to talk about it in the corresponding part. So here you have an example, etc. You can see verbs in red color. So this is part speech tagging. You can see that words have been tokenized. Also here you can see the lemmatized form. So words are reduced into their base form. Another task is called chunking or shallow parsing. Here you want to collect tokens together in order to form some chunks. Chunks can be something like noun phrase, verb phrase, prepositional phrase, etc. Another task is parsing. Here's an example of something called dependency parsing. So in parsing, we want to say, we want to understand the structure of the sentence, where's the verb, where's the noun, where's the subject. Another task, which is very important in NLP, is called language modeling. Language models predict the probability of sequence of words. So we know that in English, the cat is small is more likely than the sentence small the cat is. And one direct application of language models is to predict what is next given a sequence of text. So if I say something like Riyadh is the capital of what, the machine will predict probably Saudi Arabia. And I'm sure that you all of you have used autocomplete in iPhone or Android. So it's basically language model. And language models used to improve other tasks like speech recognition, machine translation, OCR, information retrieval. So for instance, in speech recognition, if I say something like recognize speech, probably it's the second sentence, not the first one, given that it's more likely to happen. And yeah, NLP approaches. How can we build an NLP system? We can divide the approaches into three categories. Rule-based NLP, where linguists write explicit rules. For instance, something like if you see ER at the end of the word, it's token. Like reader become read ER. Classical machine learning or statistical NLP, people or humans extract some features and then machines learn rules. Hello? I think someone is not muting their mic. Okay. The third approach is deep learning, where machines learn the rules and features. You don't have to design or engineer features. Each approach has its advantage and disadvantages. For instance, rule-based NLP it's easy to understand. If it's useful if the domain is limited, if you know the rules. However, it's time-consuming, hard to scale. It performs very poorly when rules are not followed. Classical machine learning uses less computational resources when you compare it with deep learning. It requires less data. However, it doesn't capture semantic. For instance, it's hard to capture the semantic that knows apple and orange are very similar. Feature engineering is also expensive. It's hard to generalize to other tasks. For instance, if you design a sentiment analysis system, it's hard to generalize that to something like sarcasm detection. On the other hand, deep learning approaches now dominant in the field. They can capture semantics. They allow something called transfer learning. So you can learn tasks, sentiment analysis, and transfer what you have learned in that task to other tasks. Also, deep learning approaches learn representation automatically. You don't have to give explicit representation for the data. However, they require a huge amount of data, and also they require extensive computational resources. As I said, machine learning approaches are dominant in NLP nowadays. And in the last couple of years, deep learning became very popular. However, all approaches still in use, depending on your application. Sometimes rule-based methods can be best. For example, if you have like a legal document like that and you want to extract articles, sometimes it's just the easiest way is just to do some regular expression and write some rules in order to extract the articles without the need to create some complex machine learning model. There are a lot of NLP tools available online. Some of them are free, some of them licensed. Perhaps the three most common NLP tools are Spacey, NLTK, and Stanford Core NLP. Spacey and NLTK are written in Python. Unfortunately, they don't support Arabic very well. Core NLP has some Arabic models. And for Stanford Core NLP, you can use it like a server and communicate with the server using any programming language. There are different domains in which you can see NLP as a direct application. Healthcare is an instance. People do medical document analytics, and finance, or what's called now fintech, financial technology. People use NLP to do some financial sentiment analysis in order to forecast the future prices for stock market. Marketing also is another domain where people do something like product sentiment analysis. You have products to study and analyze how your customers feel about your product. Are they positive? Are they negative about it? Law is also another domain for NLP. So let's go now to talk about Arabic NLP. Generally speaking, Arabic NLP is harder than English NLP for different reasons. For the nature of Arabic language in comparison to the English language. Also, there are less resources, less data sets and tools for Arabic NLP when you compare it with English. And there's less research has been conducted on the Arabic NLP. And there are challenges in the Arabic NLP due to the nature of the Arabic language. Orthographic inconsistency. People spell words in Arabic differently. Also, another challenge is morphological complexity. I'm going to talk about it in a moment. Dialectal variation. People pronounce words and letters differently, like the letter qaf can be ka or ka or qa, depending on your region. There are also variation in lexical and morphological representation. This is an example where people spell the same word differently. This is an Egyptian dialect, maybe Olhaj. You can see that people do not agree on one spelling. Here's the frequency for each word used on Google engine. So you can see there's no consistency in the spelling. Another challenge is morphological complexity of Arabic. Arabic, unlike English, is morphologically rich, which means that a core word has many inflected forms. Like here, you have qala, qalat, qulta, yaqulu, etc. While for English, you have only up to 6 forms for any word. So you have say, says, saying, said. And word in Arabic carries a lot of information. You can see here وَسَنَقُولُهَا has translated into, and we will say it. Just one word translates to 5 words. The third challenge is the variation in Arabic dialect. You can see here one word, which is now in Fusha or MSA, is Al-An. In Riyadh dialect is Al-Hain. In Jeddah is Dahin. In Cairo dialect or Egyptian dialect is Dilwati. You can, there are some examples of morphological variation for different parts of speech in Arabic dialect. And I'm going to talk about some common pre-processing in NLP. Usually when we do some Arabic NLP, we start with some pre-processing. One common step is to remove diacritics or harakat because they usually don't add any meaning and they add some noise. Also, we normalize characters that frequently mistyped by people. Like Tamar Bota, we normalize it to Ha. We drop Hamza, like Hamza on Aleph or under Aleph, we drop it. Also remove repeated characters or tatwil or kashida. These are common pre-processing techniques for the Arabic language. Also, there is something called transliteration. Transliteration is the step of the process transferring words from the alphabet of one language to another. So in this context, you want to transliterate or convert Arabic script into Latin script. Here's an example of salam in Arabic script and Latin script. And this is useful to avoid some coding issues, or if you deal with a system that does not support Arabic script. Also, you can read in many scientific papers about Arabic NLP that people use some translation scheme because they assume that readers, maybe they can't understand Arabic script. One commonly used transliteration scheme is backwater transliteration. It uses ASCII only ASCII letters, and it's one-to-one representation. So each Arabic letter is represented by one ASCII letter and vice versa. It includes all the Arabic letters plus the diacritics and other characters like Tamar Bota, Hamza, etc. One task which is very important in Arabic NLP is dialect identification. So given a piece of text, you want to say, okay, which dialect is this? Is it in Najdi? Is it in Hijazi? Is it in Egyptian? And the task can, or dialects can be fine-grained or coarse-grained. Like, do you want it to region level? Like, this is Gulf dialect or Levant dialect. Or maybe you can divide it by country or city or even subculture within city. And there are different base sets and tools for Arabic NLP. I'm going to briefly talk about some of them. Madar, it's part of Madar project at NYU Abu Dhabi. It's still under development and not released yet. It's a parallel corpus of more than 25 cities from Arab world. And it's a translation of the basic traveling expression corpus. Sorry. Yeah, you can see here some examples for sentences in standard Arabic and in different dialects. Like here you have Jeddah dialect and Riyadh dialect. You can think, yeah, it's here. You have the corpus here, and you have also lexicon viewer. You have some words and their corresponding translation in different dialects. Another dataset is Arab Tweet. It was released in 2018. Contains about 2.4 million tweets from 11 regions in the Arab world, covering 16 countries. The corpus was collected from 1,100 users on Twitter. Also, the corpus is annotated with age, gender, and dialect. So for each tweet, you know the age of the person, the gender, and their dialect. Another, I would say, model, more than a dataset, is the ArabBERT. It's an Arabic language model based on Google's BERT. It was released recently, 2020, and it was trained using 70 million sentences or 23 gigabytes of data. Using, I think, Wikipedia and other corpora, and it has two versions. ArabBERT version 0.1, it's not segmented, so words are just written as originally collected, and the other version is segmented. So they use some segmentation scheme to segment words, and then they use BERT to train on the segmented text. Another model that's based on ARA-BERT is the multi-dialect Arabic BERT. They used they used ARA-BERT to initialize their weight, and then they continue training using 10 million Arabic tweets covering different Arabic dialects. So the first one here, ARA-BERT, is an MSA or Fusha, while multi-dialect Arabic BERT is in dialect. And there are different NLP tools. I'm going to talk only about 3 of them: Madamira, Camel tools, ARANet. So Madamira is a morphological analyzer. It was an effort by different academic institutions, Columbia University and other universities. Currently, it supports Standard Arabic and Egyptian Arabic. People are working on extension to other dialects, including the Saudi dialect, particularly Riyadh dialect, Jordanian dialect, Iraqi dialect, Moroccan dialect, etc. And it's written in Java. It can be used as a standalone application. You give it some text, gives you an output. Like it does some morphological analysis. I'll show you in a moment. You can use it in server mode using different programming languages. You can communicate with it, or you can use it as a standard Java API. So here's a demo of Madamira. This is just a demo. The actual application is jar file. So you can see here something like part speech tagging. These are verbs. You have nouns. You can see here حذرت as the verb, and the gender is feminine, singular, etc. And Madamira is licensed for commercial use. You have to pay in order to use it. But for academic use, if you have like university email or something, you can ask for free version. Another tool or set of tools is Camel tools. Were released recently. It's a collection of open source and Arabic NLP tools. They have some pre-processing procedures like transliteration, normalization. They have also named entity recognition, sentiment analyzer, dialect identification. You can see it here in Google Colab. I'm going to share the link how to install Camel tools on Google Colab after the talk. So here you have transliteration. You have like Assalamu alaikum in Arabic script, and here you have the corresponding backwalter script. Normalization is here. You remove hamzas, you normalize ta marbuta. Here you have named entity recognition. Like in this example, شركة أرامكو مقرها مدينة ظهران, etc. So Aramco is recognized as organization, Dhahran as location, Amin and Nasser is as a person. Here we have dialect identification. Have 5 sentences written in different dialects. So first one, وش فيك تتكلم كذا. The system recognized that as Riyadh dialect. إيش بك تهرج كذا. It's a Jeddah dialect. أنت عاوز مني إيه. It says Aswan dialect, which is in Egypt. Also, there are quoted examples from, I believe, songs. First one here in Moroccan dialect, and here in Beirut dialect or Lebanese dialect. And so let's say the third example, أنت عاوز مني إيه. We can print the probability for each dialect instead of what is the top predicted dialect. So you can see that the top dialect here is Aswan. The second one is Cairo, then Alexandria. So the system ranked them, I would say, correctly, because they are very similar. Especially when you have very short sentence, it's hard to tell exactly. which dialect if you want to predict exactly which city. Another tool for Camel tools is sentiment and the sentiment analyzer. Here are 3 sentences. The first one is positive, أنا بخير, or I'm good. I'm not good, or أنا لست بخير. It's negative. So it also learns the negation. Although all words are positive, but because it's negated, so it's predicted it as negative. Third example is just neutral. It is not positive or negative. I tried some examples in different dialects, and it works very well. This is in Riyadh dialect and in Jeddah dialect, and it was predicted very well, very correctly. Third collection of tools is ARNet, was released recently. It's a deep learning toolkit for Arabic social media. It has a set of pre-trained BERT models fine-tuned with age and gender, dialect identification using Arab tweet, dataset, emotion, irony, and sentiment. So in conclusions, would say that Arabic NLP is harder than English for different reasons. It has less resources, less research has been conducted on Arabic NLP, also due to the dialectal variation. Arabic is harder than English. Arabic is morphologically more complex than English, and all of these add extra challenges to Arabic NLP. There are some good news. In recent years, there has been a lot of research conducted in NLP in general and Arabic NLP in particular. There are more available datasets and tools, and I would say you can expect that in near future you will see lots of new applications for NLP and Arabic NLP specifically. Also, if you have any application or something, I would say there's no best solution that works for everything. You might need sometimes to develop your own solution or come up with new solutions. I hope you enjoyed the talk. Thank you so much, and I'm happy to talk to take any questions. Thank you.
Thank you so much. Thank you for this great presentation. So now we're going to take some questions to reply to. So please post your questions in the chat. We have a question from our team member, Hassan, is asking about words in English and many other languages are splitted by the space character between them. In Arabic, some nouns can be connected to prepositions and proverbs. How we can overcome this issue to split Arabic words?
Okay, if I understand you, you say in English you just split words using spaces, but it's not always the case, because in English sometimes you have, if you write something like you are with apostrophe, this. Let me show it in the chat. So it's not always the case. We need some morphological analysis. In Arabic, we use something called morphological analysis. So I show you an example of Madamira here. You can see here that tokenized forms, it does tokenization. So you remove the L or the from the word, or you split it into Al and Mudiriya, and so forth. So also بمشيئة ba is splitted. So بمشيئة split into 2 words. Does that answer your question? Okay.
Yes, there is questions. I'm sorry. One of the main challenges with Arabic NLP is the shortage of the training data, especially in difficult tasks like question answering. What would you recommend to overcome this challenge?
To overcome this challenge, it's hard. I mean, people still developing other tools and data sets. I would say try, nowadays we have strong language models like BERT. Try to, instead of training everything from scratch, try to use pre-trained models and fine-tune it on your task. If you don't have data, sometimes you can't learn anything. This is general machine learning. I mean, you want to do question answering, but you don't have annotated data. So yeah, either you build your own data or there's no solution, I would say, if you don't have labeled examples.
Okay, thank you. Another question is, can we apply the same data pre-processing steps followed in English? Any steaming tools?
So yeah, not always the same. I mean, Arabic, for English, you don't have normalization for Tamarbuta, for instance. But yeah, pre-processing is done in different languages. Like in English, sometimes you normalize letters into lower cases. Like capital, you make it small, and you reduce the noise by adding capital and uppercase and lowercase, I would say. And yeah, different tools like Spacey and LTK, they do a lot of normalization.
Okay, thank you. What is another question is, what is a new method in this field?
A new method in this field? What do you mean exactly?
Maybe she meant advanced methods, modeling methods.
Yeah, I would say recently people focused more on language modeling, like BERT and other language modeling techniques using transformer architecture. So yeah, they models like BERT has shown that they can improve a lot of tasks, and they can achieve state-of-art performance without the need of large data sets. So you pre-train the model in general text, unsupervised way. Then you just use this pre-trained model on like sentiment analysis data set without the need of huge data for sentiment analysis. So yeah, this is a new advancement in the field. I would say language models based on transformers. You can read about BERT and other like Elmo. Elmo is not based on transformers, but it's like the language model. GPT-2 or GPT-3 also other examples.
Okay, thank you. Another question is, what's the difference between the tokenization and segmentation?
Tokenization and segmentation, they are used, I mean, it depends on the context. They are usually the same. Tokenization is splitting words into token, segmentation into segments. For some languages like Chinese, we use segmentation more often because the structure of Chinese language. But for Arabic, usually tokenization and segmentation, we mean the same thing. Yeah.
Okay, thank you. Another question is, language is changeable with time. So with NLP, consider that in the next years.
Yeah, this is the main challenge. I mean, if language does not change, we can just come up with rules and that's it. But yeah, it changes every day. So yeah, this is a challenge for NLP, I would say.
Okay. Some audience want to know how to install the Camel tool for the
Camel tools for yeah, here in Google Colab. I will share it with you. It's easy to install. I mean, you can go to their GitHub and find the installation steps. But I have these examples on Google Colab, so I'll share it with you how to install it on Google Colab.
Okay, thank you. Can you shed another question is from Abdulillah. Can you shed some light on the work you've done on publishing an noted Najada corpus? Can we help improve it somehow as an open source community?
Publishing the corpus, can you help improve it somehow? Any favorite technical books on NLP? Yeah, for my Najdi corpus, it's annotated corpus with morphological information. It's available, I believe, in NYU. If I'm happy to share what we have done. We annotated corpora and different dialects: Najdi, Yemeni, Iraqi, Syrian, with morphological information. So yeah, I'm happy to share it. For technical book, for Arabic NLP, I would say Introduction to Arabic NLP by Nizar Habash. It's a very good book. Other than that, there are a lot of communities, like in NYU Abu Dhabi, they have good labs. You can see the resources they have. Also, I'm happy to share some resources with the Google Colab here in my GitHub. I will share it with you after the talk.
Okay, thank you. Any other favorite technical books on NLP or resources?
Actually, for me, I usually read papers more than books. I'm not like a big fan of books, to be honest. I read more scientific papers more. I mean, everyone has, but yeah, there's a famous book by Dan Jarfisky at Stanford University. It's taught in different schools. So this is perhaps one of good academic books. Other than that, I use the internet. I read papers. There are some technical articles. Yeah.
Okay, thank you. Any recent work that impressed you in NLP?
Recent work that impressed. I mean, it's hard to tell if there's one single word, but yeah, I mean, I mentioned that before. Advancement in language models like BERT, GPT, etc. They changed the field. They completely changed the field.
Okay, thank you. I think that's it. Back to you, Rinad.
Okay, thank you so much, Sakhar, for your time.
Thank you. Thank you so much.
And the very interesting information you have just given to us. Thanks. And thank you to all the attendants. We really appreciate your time. I would like to remind you all about the PyData Global Conference that will take time at 11 November, inshallah. So please, if you need to know more information or to register, visit PyData Global website. Thank you, and thank you so much. See you in our future events. Thanks.
Thank you so much. Bye-bye.
Thank you. Bye-bye.